What do we talk most about in this country? The great British weather. We're obsessed with it. It's virtually a part of our culture.
My head is seriously full.
But sometimes it can turn from being a mere talking point into something deadly. In Britain's worst weather, I'll be investigating some of this country's most extreme weather events.
Can't move.
To find out how they're caused and why they're so dangerous.
Inside these thunderclouds somewhere over Britain, vast forces are creating one of the Earth's most spectacular phenomena: lightning. Lightning is one of our most mysterious and disruptive forces. I'm a lecturer in geography at Oxford University, and I've always been intrigued by lightning's raw electric power. Hello, my name's Nick Middleton, and I'd like you to join me on a journey chasing lightning, part of Britain's worst weather. On my journey, I'll discover how lightning's created and what happens if you find yourself in the path of a lightning bolt.
I was wearing a silver chain, and that just heated up white hot. That just sunk into my neck.
I'll discover why it sets light to some buildings, but not others.
I need to get off this hill, quickly!
How we can fly into a thunderstorm and still remain safe. And I'll look at a lightning storm that lasted a month and became one of the worst ever to strike this country.
There was just this tremendous light in the sky, and split seconds after that, the crash.
We've all created static electricity by rubbing a piece of plastic over a carpet. And I'm producing static electricity with the help of this machine. Amazingly, 300,000 volts are passing through me. But it's not the voltage that kills, it's the current, the ampage. And there's very little current in static electricity, so I'm safe. Real lightning is a lot more dangerous.
In any thunderstorm, lightning can be lethal. Each year, it kills more than 1,000 people around the world. Bolts like these can be 10 miles long, but less than an inch thick.
Lightning is a gigantic surge of electricity in the raw, a strike with the power to destroy anything it hits. The current often runs into tens of thousands of amps. Compare this with the average feed in your house of just 80 amps. Most people are killed or maimed outside in thunderstorms, but even inside, you're not entirely safe.
And I've set up a little simulation of a home office here to demonstrate that. Being inside a house is safer than being outside, but lightning can find wires and travel down them, to your telephone, to your computer. And what I'm about to show you is what would happen if a lightning bolt, typically 10,000 amps, were to hit your home office. And don't think other areas of your house are safe. Imagine coming home from work, turn on the telly, put your feet up. Now that could be a serious mistake if there's a lightning storm going on outside.
And it would probably be unwise to answer the phone during a lightning storm.
Yes, well, there you are. I should start buying more expensive footwear. That's what happens if you get struck by lightning. It usually enters somewhere in the top half of your body and exits through your feet and does that to your footwear.
And in case you're wondering, the strike didn't actually hit my foot. We zapped a dummy leg wearing one of my shoes. Joe Hemmings was unfortunately outside when he was hit. He was on a snowboarding holiday with a group of friends in Wales last year.
I got hit in the back of the head, by the strike, but as it came down past my ear got blown out, basically. It travelled round my necklace, down the front of my chest, and then split down both legs. My left train was just obliterated completely. All my clothes were just shredded.
Do you have any long-term effects?
Well, I'm still completely deaf on my right side. The doctors say it could clear up, or it could not.
Electricity is conducted easily through metal, but when a lightning bolt hits a non-conductor like the human body, it produces catastrophic effects: burns, heart failure and damage to internal organs. Joe Hemmings spent a week in intensive care.
I've got a lot of scarring.
What happened to your friends? Were they affected?
Yeah, they got a large shock from the lightning. They had minor problems. They couldn't move their legs properly or feel their legs. Speech had gone. Some eyesight had gone.
Joe Hemmings was hit by a bolt of lightning from a thunderstorm. Thunderstorms need 3 key ingredients: warm, moist air, which is unstable. Should it form a tower cloud, lightning is generated when ice particles bang into each other, creating an electric charge. Remarkably, it's possible to track lightning, and I've acquired an instrument for my laptop which can find any lightning strike within a radius of 200 miles.
Lightning strikes create powerful radio waves, and these can be transmitted halfway around the Earth. Monitor the frequency of the radio waves, the frequency of the strikes, and you get the intensity of the storm. And I think I've got one here. So we've got several systems moving up from the south coast.
Each red flash is a lightning bolt smashing out of the sky as it happens. And a green square represents an individual thunderstorm producing 20 lightning strikes per minute.
Lightning strikes per minute is around 8, 9, 10. Bing, 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 bing. In slightly different places. I think we must have more than one system here.
I can plot lightning as it happens, but crucially, is it possible to predict where it will strike? I've come to the London Met Office to talk to the experts. Alex Hill, their senior meteorologist, has a toy much larger than mine. It plots lightning as it happens around the world.
Each one of the red crosses is a lightning strike occurring at that point in time.
As we speak, how many lightning strikes are going on around the world?
Hundreds and hundreds and hundreds every second, not just every hour. And by the time you add them all up over a period of a day, you're easily in the millions.
So could Alex Hill and his team predict when and where lightning will form from thunderstorms?
What I wouldn't be prepared to say is there's going to be a thunderstorm at the end of Oxford Street at 3:25 tomorrow afternoon. I'd be happy enough to say it will be raining in Oxford Street at 3:25 tomorrow afternoon, but I wouldn't be happy saying there'll be a thunderstorm.
We can plot lightning, and we know something of its power, but alarmingly we can't predict where and when it'll strike. So how much danger are we in from lightning strikes in this country? I aim to find out as I investigate the biggest lightning storm to hit the British Isles in the last 40 years.
Bolt of lightning came straight down the antenna and just exploded.
I'm on a journey through Britain to discover how lightning's formed, what damage it does, and how we can protect ourselves from its awesome power. Back at the Met Office in London, I wanted Alex Hill to tell me how damaging lightning storms are in this country. He produced maps of one of Britain's worst lightning storms of the last 40 years.
How bad a problem is lightning in this country, Alex? I mean, what's the sort of strike rate per square kilometre?
It's very, very variable across the season. I've got a map here that shows you what it looked like in August 2004. Each of those red triangles is a lightning strike.
Virtually all of England, except for the southwest, is red.
Yep. And so if we go forward a month into September...
Oh, virtually nothing.
Same year. Virtually nothing's all quieting down.
Yeah.
So what happened in the month of August 2004 that had turned the map of the British Isles vivid red with lightning strikes? Mainland Europe was suffering an unprecedented heat wave. Southern France was ablaze with forest fires, and with the temperature stuck in the 90s, people were dying of heat exhaustion. This hot, moist air was meeting colder, unstable air as it swept across the Channel, producing gigantic thunderstorms. Stuart Robinson, a severe weather researcher, chased the August 2004 lightning storms. On one laptop, he showed me weather radar maps for that month, and on another, lightning strikes as they happened each day.
August 2004, more thunderstorms in that August than any August since 1960?
Yes, that August was a very active month. It really all started on the 3rd, when we had an area of warm air moved up from northern France, and that collided with much colder air coming down from the north, and this allowed thunderstorms to initially develop over the English Channel. As the day wore on, these thunderstorms moved out across and came across London.
The worst incident yesterday happened here at Hyde Park Corner. 4 teenage girls playing in this open area were hit by lightning.
Bolting down. Nothing, I've never seen nothing like that.
I saw a man or woman flying in the air and on the grass. She wasn't lying on the grass.
She just flew into the air?
Yeah.
Thankfully, 3 of the girls have now been discharged from hospital, but 1 is in a critical condition.
Thunderstorms were actually quite intense. A jet flying into Heathrow Airport was struck by lightning, and they caused the airport to be closed. In Wallingford, 24 millimetres of rain fell in just 15 minutes. Now, these thunderstorms then moved up across Oxfordshire and into the Midlands. The South and West Midlands, electricity were lost, and there were several thousands of homes were damaged by lightning. And then the storms continued to move further north.
A bolt from the blue. John and his wife had been watching the storms from the window of their bungalow when the bolt struck the telephone pole, travelled down the phone line, took off part of the roof and blew the phone socket out of the wall.
I lifted about 2 foot from the chair when it actually went off. It just sounded like an aircraft going through the sound barrier.
1 week later, on August the 12th, 2004, the lightning storms were still going on.
So here they are, starting off northern France, Benelux countries, and coming across the Channel.
These storms were colliding with unstable bands of hot and cold air flowing across the Atlantic.
We actually had the remains of Hurricane Alex, which had crossed the Atlantic and was now approaching to the west of Ireland. Hasten to add, it wasn't a hurricane at this stage, no. But it's the warm tropical air that's mixed up with inside it. You can see now the area of South Wales on the Pembrokeshire Peninsula. And you can see there's a line of storms that's developed really from southwest Wales down to the Isle of Wight. It seems to be becoming organised into what we call a squall line or a line of thunderstorms. These squall lines are typically very intense lightning producers. And often if you could stand behind the line as it's passed over you, you'll be treated to a rather awesome lightning display.
Until yesterday tea time, this was Margaret and Gary Cooper's bedroom. Then the lightning struck.
And there was just this tremendous light in the sky, and split seconds after that, the crash. And then within seconds after that, there was crash banging on the door with the neighbours saying, get out, your house is on fire.
A hailstorm in Holt Heath in Worcestershire caused £150,000 worth of damage.
The strike rate's up to 30, 40 here, isn't it?
That is an astonishing amount of strikes per minute, but it's not unusual on a day when we get a line of thunderstorms. And if you look now at the total strikes, 4,500 strikes now, and it's only just 3:30 in the afternoon. There's still...
That's the number of strikes over the UK within less than a day.
From less than a day.
18th was a real humdinger.
Well, actually, the 18th of August was probably the worst thunderstorm day of the entire year. Some of the more intense thunderstorms occurred on the Scottish borders.
This Stirlingshire Valley is no stranger to small landslides, but nothing on this scale.
With the thunderstorms came intense rain, cutting off whole Scottish towns.
What those symbols mean on the map just over Scotland, the green squares is a thunderstorm that's producing 20 strikes per minute. A yellow square is producing 30, and the reds, quite rare, they're actually producing 40 strikes per minute just from that one individual storm. But the highest I saw that day was 120 strikes per minute for a short period of time, and a lot of those strikes really just came from 3 thunderstorms that are on the Scottish borders. The lightning risk in that particular area would have been extreme.
There were more strikes to people and fires in houses than on any other day throughout the year.
A lucky escape for the owners of this house in Basildon.
A great big ball of white which exploded into the sky, the whole sky lit up, and it was literally right outside our window and knocked the 3 of us backwards.
August 2004 was one of the worst months in living memory for thunderstorms and lightning in the UK. 23 people were struck by lightning, but thankfully none was killed. Over 130 houses were hit and damaged by a colossal series of lightning strikes. It ran into the tens of thousands that month. Scientifically, surprisingly little is known about this sort of weather event. So over the millennia, the terrifying power of a lightning strike has spawned all sorts of myths and superstitions. Wittenham Clumps Hills in Oxfordshire have always been a target for lightning. Ancient warlords once scheduled battles here when lightning appeared. Ignorance and fear made people once believe that lightning originated from dark, supernatural forces. Anyone struck by a lightning bolt was thought to be a victim of God's wrath, only curable by a powerful shaman or witch doctor. The people who owned this cottage about 300 years ago believed if they collected certain objects, they'd act like an insurance policy against the evil strikes. An owl with outstretched wings, a speckled toad, and curiously, the hide of a hippopotamus. 200 years ago, superstitious parishioners believed that ringing church bells would frighten away the evil demons that created lightning. Many church bells were engraved with the Latin phrase fulgura frango, meaning I break the lightning. The ringing of the bells may have provided courage hundreds of years ago, but bell ringing was a high-risk occupation. Without a lightning rod to protect the tower, the bell ringers themselves became a prime target for lightning strikes. Over the years, hundreds of people are known to have died during thunderstorms, while furiously ringing to drive away the devils and the demons. Even today, lightning remains much of a mystery to scientists. They had noticed that lightning sometimes appeared in the debris cloud above an erupting volcano. They had also seen it in the dust cloud above an atomic explosion. From these similar events, they believed that lightning was formed by particles being thrown against each other and producing a charge. In the 1950s, they applied the same reasoning to the creation of natural lightning inside the huge 10-mile-high anvil-shaped thunderclouds that can be found over Britain on summer days. Warm water vapour rises in thunderclouds up to the very edge of the stratosphere, where it freezes, becomes ice and hailstones. The thundercloud becomes a giant battery, a positive charge at the top and a negative charge at the bottom as heavy falling hailstones bang into lighter rising ice particles. Electrons are knocked off the ice particles, producing the electric charge.
It would be reasonable to say that it behaves like a giant battery. You have a negative charge at the bottom and a positive charge at the top. I mean, if you could harness it, it's a vast amount of energy.
The lower negative charge layer of the thundercloud automatically forms an equal and opposite positive charge on any tall object on the ground, like a tree near the cloud. As a slow negative spark leaves the cloud, it attracts an upward moving positive spark, about 100 metres from the ground. When they meet, the lightning strike is complete. Sometimes these positive upward streamers that complete the circuit have been uniquely captured on film. Any tall object, like a tree or a person, is inherently closer to the thundercloud and will launch a positively charged spark at the negatively charged cloud above. I can do this artificially if I'm close to a positive electric field. It's possible to predict when a lightning strike is about to hit because your hair will stand on end. Now, I'm creating this effect by standing in a very strong electric field, much like the same sort of thing that would occur beneath a thundercloud. If I was standing outside, I'd be in great danger because I'd be about to be struck by lightning.
So where is it safe to be if you're caught outside in a thunder and lightning show? Well, certainly not a place like this one, an exposed hill. Don't shelter under trees. They're the first objects that are going to get struck. Come along and I'll show you how. Trees, very tall objects. This one has been split asunder by lightning.
And if you're near a tree, there's the danger of injury from flying chunks of wood.
If all else fails, be prepared to make contact with Mother Earth. Find yourself a wide open space and crouch down, making yourself as small as possible. It's about as safe as you're going to get. Above all, I need to get off this hill, quickly!
Anyone out in the open, particularly sportsmen, are a target. Golfers carrying metal clubs and umbrellas that conduct electricity and magnify the strike are particularly in the firing line. Anne Dunnett was hit while playing last year.
We had played 2 holes and we just teed off at the 3rd, and the buggy came out to say that it was cancelled because of torrential rain.
The ingredients were right that day for thunderstorms. Warm, moist air rising in unsettled conditions, producing a lightning strike of nearly 500,000 volts.
And then, all I can remember is the lightning. My brolly being ripped out of my hand, I fell to the ground, then I sort of thought I'd been struck by lightning, and it was the pain going up my arm. It was like somebody gripping me very, very hard. I was taken into the local cottage hospital.
What did they do?
It had never happened to anyone before. They'd never seen it in all the years they've been there. Anyone struck by lightning, and obviously walk in, and suggested I go to the accident and emergency hospital in Aberdeen.
Anne's condition was a rarity here as well.
They never had anyone struck by lightning before, and they took my pulse and the usual, put me on the monitor for 24 hours.
Do you have any long-lasting physical scars?
Not physical, mental probably. I know I was lucky, extremely lucky, and the chances of it happening again, well, who knows? That's, I don't think I could ever be so lucky again.
The lightning threat to golfers is so severe that this Oxfordshire course monitors weather forecasts and runs its own early warning system.
It's the good old klaxon. Not very scientific, but it's loud.
Yes, and they're all aware of what that means.
Members and visitors are aware. If we do tell them there's going to be a possibility of lightning in the area, then we will say there will be one long burst on the klaxon. And that's a sign that we're actually closing the course due to dangerous conditions.
But our sportsmen have it easy compared with those in equatorial Africa, where there are many more thunderstorms. Several players were knocked unconscious as lightning bounced off the wet football pitch.
Unbelievable scenes here.
So how can we protect ourselves against one of nature's most intensive forces? Scientists have devised a way of doing this, and I'm strapped into a metal cage and zapped with 300,000 volts in an experiment to prove their point. On my journey through Britain, I found out how lightning's created and what damage it does here. Now I need to see if we can protect ourselves from these bolts that rain haphazardly from the sky. If you are struck, there's a 1 in 16 chance that you'll die. Thankfully, that only happens to 3 or 4 people in the UK each year. 150 years ago, the death rate was much higher. 20 people were killed a year, even though the population was only a third of today's. Life in the open air was more hazardous then. People worked on the land, their injuries made worse as the strike was conducted through metal tools held in their hands. Today, most of us work, travel and fly in metal structures, but they're protected from lightning strikes because of an important scientific breakthrough. Metal shaped into a mesh known as a Faraday cage keeps us out of harm's way. Time to play the experimental guinea pig again. Any particular reason why it's shaped like a mummy?
No, to be honest, it just makes it a bit more entertaining. It could be any shape at all.
Entertaining for you, scary for me. So how does it work? What's the principle behind it? The device is named after British scientist Michael Faraday, who discovered that electricity flows harmlessly round the outside of a metal cage and then safely to Earth. I'm kind of nervous that bits of me might be touching the copper. Does that matter?
That's quite all right. You're perfectly safe.
You're very reassuring, Nick, but why should I believe you?
Well, Faraday himself actually performed a demonstration based on this in front of the Royal Institution in London, putting his own life at risk potentially, and was absolutely unharmed by it.
And how long ago was that?
About 150 years.
How many volts is going to go through this?
You're going to be hit by roughly 300,000 volts.
Crucially, the electric current is always conducted around the outside of the cage and never penetrates through the metal grid. I've survived 300,000 volts surrounded by a metal cage. Will the same principle work in a slightly more realistic situation? One of the safest places to be during a lightning strike is inside a motor car. Once again, the metal frame of the body acts like a giant Faraday cage, conducting the electricity away from me. The car gets zapped, but I am perfectly safe. At least that's the theory. Let's see if it works. The car is being hit by 500,000 volts, which is flowing round the bodywork, through the tyres, into the ground. Well, I think I'm safe. Don't know about the car, though. Let's see if it still works, shall we? Not entirely surprisingly. The car is not well. But I'm safe. That's all that worries me. The same principle is used on a much grander scale to protect buildings. Today's architects turn their very first sketches of a new structure into a ready-made Faraday cage. This is the old-fashioned or conventional way of protecting a building from lightning?
Certainly the more traditional lightning rod, made of copper, as you can see from the patination on it.
Whereas that?
A completely different arrangement. You can see from the outside of the building the heavily expressed diagrid or diagonal grid structure that runs around it. So you have a continual path of conductive metalwork going right from the very top through the structure, right into the basement, down through the piles and discharging to earth.
So that the whole building effectively acts like a giant Faraday cage?
Yes, one huge Faraday cage.
If that building didn't have that metal frame and there wasn't a conventional lightning conductor on it, what would happen to it if it was struck by lightning?
The building itself would act as the primary conductor of the electrical charge, and everything within the building would be subject to the strike.
So everyone inside would be in danger?
Most definitely, yes.
Electrical apparatus, like phones, computers. Are there any other buildings that we can see from here which are protected in the Faraday cage type way?
Any building that has a large external frame, whether it's a concrete frame or whether it's a steel frame, that framework will discharge the electrical current to ground.
But without adequate protection, you get fires like this.
Lightning from the storm struck the roof of this block of flats at Tulse Hill in Brixton. 60 people, including 15 children, had to spend the night in emergency accommodation.
In older buildings, metal lightning rods connected to copper strips are laid out in a series of giant Faraday cages. A strike should find one of the cages, and a strip will conduct the whole charge to Earth.
In effect, the whole building becomes one whole Faraday cage.
I'm travelling north to the site of one of Britain's most damaging lightning strikes. It was at York Minster. The system of Faraday cages that were supposed to protect the Minster couldn't cope when lightning was flickering around the building on a hot, humid night in July 1984. No one predicted that a strike of 1,000,000 volts would smash into the lead roof. The Minster was already ablaze when Fire Chief Peter Wright and his men arrived from the local fire station.
When we came inside here, there was red embers falling down from all along the roof, falling down onto the floor. We decided then that it maybe was a better idea to fight the fire from outside. There was molten lead falling down that caught my eye in the darkness.
More than 100 firemen spent 3 hours containing the blaze.
Steve Mills was part of the building team looking after York Minster.
Pouring tons and tons of water onto the actual structure itself, which collapsed it in the end. That was the most amazing sight, to see all these huge A-frames slowly collapse onto the floor, and a terrific noise, I remember, like rifles going off as the beams cracked in the fire.
By dawn, the result of the lightning strike was all too apparent. A gaping hole in the roof and damage throughout the fabric of the building. I climbed to the new lead roof of the Minster with Steve Mills to investigate where the lightning struck in 1984.
Right, this is the South Transept walkway. This is where the seat of the fire was.
So this is where the lightning penetrated the roof?
This is where it penetrated, the weak point, if you like, the point of least resistance.
Yeah.
In that sense.
Inside the roof space below, I saw why the lightning had caused such a catastrophic fire.
It's quite possible you could get something called flashover, which is where the lightning actually strikes the leadwork or a lightning conductor and then pierces through the roof onto anything metal inside. We think it hit a control box system for the floodlights outside on the roof.
Any idea of what sort of voltage the roof would have been at?
It's very difficult to be exact, but it could have well been in the millions of volts.
Really?
Yeah, absolutely.
So why did the Minster's giant lightning protection system fail? Rods anchored to the lead roof were meant to conduct strikes safely to Earth. But it was discovered that the lightning rods were spaced too far apart. The huge charge jumped between the conductors and caused the fire. The chance of being struck in a building is low, but thousands fly each day in aircraft full of fuel close to lightning clouds. A commercial long-range jet is struck by lightning on average once a year, so each new plane must be specifically designed to keep it safe from catastrophe. In the past, some of the most serious lightning incidents have involved fuel tank explosions. Many believe Flight TWA 800 blew up in 1996 because lightning caused fuel vapour to ignite. Over 200 people died.
The debris holds vital clues. Signs of explosive burning might point to a bomb. There is no evidence so far.
The new Airbus 380, which carries over 600 passengers, is a giant Faraday cage, but it also carries hundreds of tons of fuel. To ensure safety, some parts of this massive plane were tested to destruction at Britain's leading lightning laboratory, run by John Hardwick. This unique footage shows what happens when a plane is hit by lightning.
If you look at this first frame of the picture, you can see that the lightning is branching upwards towards a cloud, and that's very suggestive that the aircraft triggered the lightning itself.
The simple presence of a large aircraft near a thundercloud is responsible for producing nearly all lightning strikes on planes.
I've certainly been on aircraft where lightning strikes have occurred, and you're aware that a strike has happened because you get this sort of sudden white flash in the aircraft. Because it's metal and because it doesn't have any charge to begin with, as it flies into a storm, it will gather that charge.
The lightning has to go into the aircraft at one point and out at another.
Windows are weak points. Lightning produces strong electric fields which penetrate glass windows, effectively holes in an aircraft's metal Faraday cage.
This fast-changing magnetic field can induce a voltage or current on the aircraft wiring.
So to avoid disaster, vulnerable computer wires and control cables must be kept away from window areas.
If you had a strike on the fuel tank of the wing skin, the arc could melt a hole when they get a fuel explosion.
200 million people fly each year through British airports in huge planes packed with tons of fuel in their wings. Metal wings make a better Faraday cage, safer from lightning strikes. But today's giant planes save weight with parts made from special carbon composites, a poor Faraday cage, increasing the risk of fuel explosions.
This panel is typical of a wing construction, say about 2 millimetres thick of aluminium alloy. The only damage where you have a simulated lightning arc is some pitting. This is in contrast to carbon fibre, which people are now beginning to use to construct aircraft out of. It's 1,000 times worse conductor than aluminium alloy, so there's a lot more heat produced when the lightning current flows in it.
Add a metal mesh to the carbon composites and you've created a better Faraday cage. The current from the lightning strike flows around the body and won't penetrate. With parts of commercial airliners increasingly made from lightweight carbon composites, much of the work here goes into finding a safe thickness and size of mesh in wing panels.
What sort of voltage or ampage are you zapping it with?
We use a test current of 200,000 amps and a voltage of about 80,000 volts. And it's probably the most severe test that you can apply to an aircraft part. A few seconds. There's quite a lot of damage there, and you can see what's happened is the copper mesh that was protecting the surface has all vaporised.
Although the panel failed, engineers now know to make the copper mesh thicker if it's going to survive the worst lightning strikes.
But if that bit was over a fuel tank,
then I think we'd have every reason to be a little bit worried about it. This rivet here seems to have become loose, and if it's become loose, there would probably be a spark on the underneath of the panel in the fuel area, and then, of course, you have gaseous vapours and ignition, and unfortunately, no wing, no plane.
By clever use of a metal cage, some of the serious effects of lightning can be contained. But there is now a new factor in the equation. Scientists believe that as the world heats up with global warming, there'll be more lightning strikes. To find out what this will be like, I go to a country in Africa where there are hundreds of thousands of lightning strikes every day. I found out how much lightning there is in Britain, but scientists warn we could expect a lot more in the future. As the world heats up with global warming, lightning strikes are likely to increase. Now I want to know what effects this will have. Alex Hill at the Met Office showed me that equatorial Africa has the most lightning strikes in the world.
this is where all the action is. The Congo Basin and the Amazon Basin. And that's the lightning hotspot of the planet, isn't it?
That's the lightning hotspot of the planet.
In equatorial Africa, lightning generated from giant thunderclouds rains to the ground. So I've flown here to experience the extremes of lightning. I'm in Rwanda in Central Africa. Now, we're very close to the equator here, so the air is always warm, it's very humid, and we're surrounded by hills and mountains, which makes the atmosphere very unstable. It's a situation that's ideal for the formation of thunderstorms and lightning. I've come to see the sort of conditions that Britain, as it warms up, may one day face. Rwanda, just below the equator, is known as the country of 1,000 hills. Perfect terrain for the production of thunderstorms. Hot air gusting between hills becomes unstable. When mixed with water vapour from surrounding lakes, it fuels giant lightning clouds. Musoni Didaz, head of Rwanda's meteorological service, can spot the signs each evening.
You will get a tower, don't be surprised. The towering may go up to about 9,000 feet. And those are clouds that usually produce lightning.
And as evening wears on, we get the full works. In Britain, the average number of lightning strikes per square kilometre is less than 1 a year. In this part of the world, that figure is 80. Lightning really does rain down on Central Africa. I've brought my laptop from England with the software that looks for lightning strikes in real time, and the rate at which it's seeing strikes is quite phenomenal. It's the late 400s, 470, 480, 490 there. This machine's going crazy. Well, it's up at past 500 strikes per minute. Now, back in Britain, the maximum I've seen is around about 100. So this really is lightning central. The Rwandan authorities take lightning seriously and use radio to collect research information on its dangers.
Announcement on 89.2 Radio Flash FM. The Rwanda Meteorological Service is currently doing a survey on lightning and its effects on the people and their properties. Anybody who knows any victim of lightning, whether dead or alive, please call this toll-free number 55 10 04 8.
I talked to lightning survivors in Britain. Here I wanted to assess the dangers of more extreme lightning situations. I went to the village of Chimbara, in a mountainous region in the west of Rwanda, to collect my own data. I found 2 men who last year were out walking with a companion when a thunderstorm broke.
There were 3 of us, and the third died instantly.
1 man died immediately.
I was struck and had burns on one side of my chest.
It looks pretty painful.
It doesn't work.
I was struck in the leg and it burned my foot. Before it struck, I felt something rushing up from the ground, throwing my foot towards my shoulder.
In a separate incident here, 2 ladies were with their children when a lightning bolt hit their home.
When the thunder came, I was lighting the fire so we could cook. I was holding the child, but I don't remember how I fell down. When God woke me up, I found myself under the bed. I was trying to shout to the other lady, "Please help me, my son has died."
Tell us about your little boy. What happened to him?
The child has injuries, and sometimes he has a high temperature. He was burned on the left-hand side of his chest.
As in Britain once, there's much superstition about lightning here. A local shaman has to reassure lightning victims they won't be struck again. as well as offering cures for their injuries.
If someone in the village is struck by lightning, how can you help?
I treat them with this medicine, these leaves. They call me and I come and treat them. There is a leaf which I make them drink with water, and I rub others into the burns.
And after that, the victim will never be struck by lightning again?
No.
A successful operation then?
Rwanda has on average a staggering 210 days of thunderstorms in a year. In Britain, we have less than 10 a year. So with global warming, can we expect thunderstorms to increase in Britain?
If global warming persists, there is a probability that we will see more lightning storms. Why? Primarily because we're going to see warmer atmospheres and we're going to see warmer seas. This means we're going to get a lot more storm events, a lot more rainfall, and so we're going to get a lot more storm clouds produced. So we will see an increase in lightning.
It'll be some time before the lightning strike rate in Britain gets close to that I'm seeing here. But it has been estimated that for every 1 degree C temperature rise, on average, in the British Isles, we'll get 40% more lightning.
We may all like the idea of warmer weather, but it comes with its own hidden dangers.
Coming up next on More 4, Tony Robinson and his expert crew have 3 days to dig up the remains of a superfort in Herefordshire. That's Time Team next.